Alrighty then, let's get started. Is my voice clear?
Yes, sir, it's clear.
Okay, thank you. All right, so today we're going to start with easier questions, and then we're going to slide into medium level for the arrays. Well, this is not the medium one, but these two are the medium ones. The other day I was trying to explain this question right here, the maximum product subarray. But then I mistakenly missed out on these important questions. Before you get to this question, I think you should solve this question if you're a beginner, and this will give you a good idea about how you can, what are the other ways you can operate within an array, just like right here, So let's go to this easy one, valid anagram. Can anyone tell me what is an anagram? Has anyone solved this problem before?
Solved anagram is a word which is same from the if we go from right to left and if we go from left to right, it announced or its letters are same. Like if we
Right.
say about
That's a
uh
palindrome.
yeah, so it is like that. I think so.
No, that's a palindrome actually. That definition stands true for a palindrome, but an anagram is something. Thank you for your input, by the way. You can hover over your cursor and it's going to tell you an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Okay? So if I were to take this word anagram itself here, if I were to scramble the letters, I may end up with a new word or phrase. That may make sense, that may not, but uh, there are a couple of rules you have to keep in mind. The first is that the size or the number of letters, the total number of letters in the actual string or in the actual input has to be equal to the anagram, right? So this right here, anagram is anagram of the anagram, right? That's one condition where the lengths are equal, right? The lengths are equal. And the other rule is going to be that um, each letter right here in the anagram has to be used only once, has to appear only once in its anagram. And that is the only way when you're keeping in mind these two conditions, the length and the number and the frequency of the letters. So if these two are consistent within the anagram, then you could say that one is the anagram of another and another can be an anagram of the previous one. Depends on how you like to see it, right? And let's go to the question. We'll read the question and try to see what they're expecting us to do with these anagrams, right? Um, Given two, let me zoom this one in because I think you guys will have a little bit trouble seeing it. Given two strings S and T, return true if T is an anagram of S and false otherwise. Okay? You're given two strings S and T. They're expecting you to return true if the T string is the anagram of S. Simple as that, right? And the rules I've told you is that the length have to be equal. The lengths have to be equal. Second, the letters have to match. The letters have to match where the frequency of A is equal to the frequency of A that occurs here. So this letter right here appears only once at this inside this string, right? But if you look here, like in literal sense, it's appearing thrice. The idea of telling you that a letter can be used only once is that the frequency has to be the same, right? You can use these letters multiple times, but you cannot exceed it or you cannot reduce from the limit. Okay, so I hope you guys understood what we're able to get what an anagram is, the basic definition of an anagram. And now we need to determine whether our T string is anagram of S. Okay, and if it is, we return true. If it is not, we return false. Okay. All right, so how do we solve this? Can anyone suggest an approach to try to solve this?
The one approach that comes to my mind is that if we if we save them in a hash map, each letter be the frequency, the S, if we take the string S and save the frequency of each word, each letter, each letter, and then we will start reversing the string T, and then we will see if the frequency of that letter matches with that or not. For example, if it exists in the um, string T, we can subtract one that from the strings S, and in this way we can see either at the end we can check either the string S is empty or not. If it is empty, it means that it matches, and if it is not, we can say that it is these are not the anagrams.
Okay, so let's take an example with your approach, okay? So let's say if I have S equal to car and T is equal to ACR, okay? Now, what is the first step I should do?
Okay, so you have to save it like C. First, we are going to iterate the string C, and where we are going to add C is equal to R. Sorry, C is equal to 1, A is equal to 1, and R is equal to 1.
Okay.
The value would be number of time it appears in the string. For example, let's say if S string would be CARA, then A would be 2, right? Yes, equal
Correct.
to 2.
Okay.
And then we will iterate string T, and we will see if A exists in the map or not. If it exists, we are going to subtract that element by 1.
Perfect.
And then if for the letter C, the value would be 0. And for letter R, the updated value would be 0. But we will see that now, no, it is basically 1. We CARA and ACR. Okay.
Perfect. Actually, these have to be anagrams, right? We're taking a happy case scenario, right?
Okay, that's fine. Now, as it is empty, every key in the map has 0 value. We can say that both of the strings were anagrams. And if in case it wasn't the case, we can say that these were not the anagrams. I mean the true and false case.
Perfect.
That we have to return.
Yeah, but there's one step I think we're missing. Maybe you mentioned and I missed it. What's the one step? Once we have all of these zeros, we still have to iterate over it to see if all are zeros, right? Or do we have a better approach?
So I haven't thought about the coding perspective. I was also thinking what could be the time complexity and the space complexity. I think the space complexity would be big O of n, because we are storing every element of string C.
But we haven't finished our solution, so we shouldn't actually jump to the space or time complexity yet. This is a very actually, I think this is a very important point. Once you have all of these zeros, what do I need to do to determine that it is an anagram? What is that one step that can determine? One is like I can iterate over each key and see if it is, and then I'm doing like a whole bunch of iterations, or maybe like few, depending on the size of string and variation in the string. The other approach I'm thinking, unless you have one, is that anytime any of my keys are being set to 0, can I remove this key value pair altogether from the map? Eventually, yes, exactly. So that's what we're going to do. That once our map becomes empty, at the end I can check if my map is empty. If it is empty, yes, I found anagram. If it is not, then I need to return false. So what would be the time
Okay.
complexity for this?
Okay, the time complexity would be big O of n, because we are using the two loops but independently. These are not the uh, loop inside a loop. So it would be big O of n, I guess so.
Yes, it is.
And big O of n space complexity.
Space complexity, yes. Yeah, that's the worst, space complexity. We're not increasing the size of dictionary more than the string itself. So yeah. Okay, yeah. Najma, I guess Najma has a question. Please go ahead.
In the first step, we will check length of both S and T. If they are equal in length, then we will approach further with the approach Mahazainab has. If they have not equal in length, then we immediately return false.
Perfect. Yeah, that's an edge case. It's called an edge case, right? So great job. I think the first thing we should do is check if the lengths are not equal, right? So I'm going to go ahead and start implementing the code. If you guys have any question, you can ask me. Stop me if you don't understand any part of it. And then we can convert it to Python code if necessary. All you have to do is just ping in the chat. All right. So first I'm going to check if the length of the S is not equal to the length of T string, right? In that case, what do I need to do is I just simply return false, okay? I just simply return false. Return false, okay? Else, I talk about having my hash map. Can someone tell me what's the difference if I had initialized hash map here, but why did I choose to initialize hash map here after the condition? Can someone tell me that? Anyone has an answer?
So in this way, if you initialize the hash map in advance, I mean, if they are not, um, you are creating space without checking that. If we before comparing two strings, if we know that they are not equal, there is no need to occupy the space or something like that, or execute the code. You can immediately say that it's not, these strings are not anagrams.
Right. So we are utilizing unnecessary space for initializing an object. So we can totally avoid that by uh, running our edge case first and then initializing our hash map. So we don't have to worry about, or compiler doesn't have to worry about, or if you're using Python, I think you guys have interpreter in Python that doesn't have to worry about initializing or using memory unnecessarily, right? So when you talk about large code bases and big scale applications, there are these optimizations. These smaller optimizations actually matter a lot. So okay, so let me explain you this code. What I did here is I am iterating upon the S, which is a string, right, with the character C, and then I'm putting the character C and mapping it to the key anytime, basically this plus one. So map.get or default, what this does is it gets the key and then it adds one to it if that exists. If that does not exist, then it will add just the key and it will assign it a value of one. Okay, if it already exists, then it will add one to it, right? Okay, and this is just an optimized way. You can write like lengthy code and all that. Now the next thing I need to do is this is being used to store elements in the map. Now I'm going to iterate over the map and then I'm going to check if a key does not exist, it's false. Iterate over T and iterate map. See, If map does not contain T, that will return false. And else what I need to do is integer dot get C. Equal to 1. Then finally I return if return map is empty. Okay. Okay, let's read this code and try to understand it. First, you're checking if s.length is not equal to t.length, you're returning false. If this condition stands false, then if this entire condition is false, I'm not saying this is false. If entire condition is false, you initiate a hash map, and then what you do is you initiate a character C, and you use for each loop or the S, okay? And then do map dot put. Your character C is being mapped to get or default C0. And need to revisit this. Get or default. Initially what I did was I was just using simply I'll get the key, and whatever the value would be, I would just check what the value it is. And then if it already exists, I would increment. If it has arrived at 0, then I would remove that element, right? But this is a GPT optimized code. I like this one better, and I thought in the session we can go through it and try to understand why this one is better. Okay. Incremented by 1. So this is basically an inbuilt function in Java. So you're getting the value and you're incrementing it by 1. That's all about it. Okay, you're mapping the value, you're mapping these characters inside the map, and then you're incrementing 1 to it. Okay, and because you need to initialize it first. Okay, and then you're moving over T, iterating over T, and map dot contains C. Exclamation mark means if the C is not present. If this character C is not present in this S that is being mapped, then you return false. It's not an anagram anymore, right? If any character is missing from the map now, then we can return false simply because it's missing a letter. Let's say if instead of, let's say this T was, instead of these commas, you had a T here, then if it wasn't able to find the T in the hash map where you stored this anagram, then it's already false, right? So you don't need to further check each and every element. If you're not finding something, you just need to simply return false. Okay, and then you are getting the integer count equal to map.getC. You're checking the count. If count is equal to 1, map.remove C. Okay. All right. This right here is a little bit tricky. I don't know why they are at count 1, they're removing it. But anyways, if you're initializing with 0, then that makes sense. If you're initializing with 1, okay. Yeah, I think this is extra. I think this is extra. We can check if the count is 0. If proper subtraction is taking place. And then this updates your value. Map.put in Java, it updates your value if C is being found. If that character is being found, then you're simply subtracting it. If C exists in that T, you're simply subtracting the value. And then you're updating your map. You're not storing it. You're not updating the value directly. You're updating the entire key map pair. You have to give the key, and then you have to give the value. And finally, when this iteration is over, then it comes here and returns map.isEmpty. How will this return true? If this statement is true, if map is empty, then this will automatically evaluate that as true. If this statement is false, it is empty, will return false. This is an inbuilt function. Okay, so I guess we have some questions. Let's see. Is there any real life example to this problem you can think of? Yeah, we use maps a lot in basically. What is map used for? So when you're writing APIs and APIs, a request comes in. So a REST API will require you to put path variables. Basically, when you're calling your database, right, you have some parameters here. For example, username. Okay, and there's an API connected to this database. Someone wants to get this user. If user has other attributes, for example, the age and qualification, right? So the one who's trying to use this API, the client or the user, the one who's trying to use this, they can send a hash map, right? It can write a hash map and send to the API and ask API, hey, map all of these values in there, user, age, and qualification, and get the map back, and then iterate over it, right? That's the very basic implementation of hash map, where you're mapping multiple values assigned to a single object. But when you're saying this specific valid anagram, this valid anagram question is just to make you think in patterns, where you can compare things by mapping, and probably derive a result out of it. Okay. This approach, you could save space. Okay, I don't know about this approach. We're gonna move to the next question now. We don't have much time, actually. Trying to get as much done as possible, but I hope this question is clear, and I'm pretty sure you guys are pretty good with it. All right, so let's move to the next question. Majority element. Okay, the question states 169, LeetCode. It states, given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority elements always exist inside the array. Okay, so what they're saying is, you have an array nums, and then you have at least one element that occurs majority of the time. Okay, and how are they defining the majority of the time? Is if that number occurs more than n by 2. And what is n? N is the length of array. Nums dot length of the array. Okay, they're saying if n by 2, if half of the length, let's say if the length is 4, then the n by 2 will be equal to 2, right? So if it is more than 2, not 2, but more than 2, if any element is occurring more than 2 times, that is your majority element, and that's the element that you need to return. They're expecting the element itself, not the index or not anything else. Okay, so just to save time, I'm going to go ahead with the solution because we need to move to the medium questions as soon as possible. Okay. All right. So what would be the solution for this is, let's see. I need to find the majority of, so I can use the same example. I can use the same example of anagram. I use a hash map. Okay. First of all, I store all these elements, 3, 2, 3 as keys, right? And how I store this is, when my iterator is I is here, if this already exists in dictionary, if it does not exist in the dictionary, I add it in the dictionary with the count 1, okay, because it has occurred once at least. Then when it appears again on another 3, it finds another 3, I increment that count with another 1, Okay. All right. Similarly, I do for all other elements. Okay. 2 has only appeared once, and this is how I map all of these values with their count. Next thing I need to figure out is there any element that has occurred more than half of the time? So first I need to compute this, store it somewhere. What is the length of the array divided by 2? And let's say the length of array is 3. 3 by 2 will be what? I guess this is what, 1.5, right? So if the 3 occurring is more than 1.5, which it is appearing twice, right? Then I can say that 3 is the majority element inside this array. Okay. And once I've mapped all these values, what I can simply do is I can iterate over this map and see which element has a count that has occurred more than the length of array. And this is the length of half of the length of the array, right? So this is a simple solution. I'll go ahead and start typing the solution so that we are saving time on this. We're not getting too deep into this. Length, nums dot length. So this is an array, so we don't need that. And I'll start a count. Okay, you can start with 1 or with 0. Better save complexity for later complexity. Better save that. Just initialize it to 1, and then you have hash map. And what you can do is integer. Oops. Oh my God, I hate this. Integer. Okay. I'll just simply name it map, and I'll initialize a new hash map. Okay. And just close it down. This is the new object. Okay. And I'll run a simple loop just to store the elements. Okay. I is less than or equal to nums dot length -1, so that it can go all the way to the last index. Okay. I plus plus, it will increment by 1. And but I will check if map dot contains key. If the map already has a key, right? And I'll just simply put a not. If it does not exist, if the key does not exist already, in that case, what I want to do, I want to map my nums of I, which is the element, which is this, for example, this is nums of I. Okay. I will map my nums of I to the key. Okay. And what I will do, if it does not exist, I'll have to write the logic for that. I'll do map.put, which will put the key, right? And it also will require value. Why? Because the hash map right here requires a key and a value. If you don't do it like this, if you're not giving it a key and a value, then it will throw an error, invalid exceptions and all that. So I want to map my nums of I, which is my character, which is my number. Okay, I want to map it to the count. So initially the count will be 1. Count has been set to 1. So I'm mapping it to count equal to 1. Okay. And then I'm going to my else condition. And in else condition, what I do is, okay, let's see. There is some issue. Okay, so let's move on. Map.put nums of I, map.get nums of I, and I'll add 1 to it. Okay, I'll add 1 to it. What I'm doing here is, if it does not contain key, just simply add it with count 1. If it already contains, if, and opposite it else, if it already exists, get the nums of I, which is the key. This function will get the key, but return its value. This function will, right? So add +1 to the value, because you have found another instance of that. Okay. And once I have mapped all these, then I'll simply run another loop. Okay, simply run another loop. This is just Java specific, so you can use Python, you can do similar thing, iterate or your dictionary. And determine if something already exists. Integer and entry dot map dot entry set. This is basically what it's doing is iterating over all the keys and getting its values, and then we can put a logic which will tell us where we'll determine if the length of a particular value has exceeded the half of the length of the array, right? So entry dot get value, entry dot get value. It's a function, right? So we have to close it with a, when we close with round brackets, which called tuple, and by 2, and we'll return the entry dot get key. Okay, why didn't we do entry dot get value? Can anyone tell me why didn't we do entry dot get value here? And then return it underneath. Can someone unmute that tell me why I'm not doing entry dot get value? It's a simple question, but just to see if you guys are able to catch up with the speed.
So we have to at the end return the number that has length more than half of the length of the array. So they ask the output should be the key that has more than, that appears more than half of the length of an array. So in this case, it would be 3.
Correct, because that's what the word was asked, right? This is just a count. So count we're using for internal operations key. Once we have determined based on our internal operations, if the count is more than half the length, we just return the key to it. That will return the number that was originally mapped from here. That is what, that's the entire summary of the question. Thank you, Maha. Okay, let's move to the next question, medium question. Okay. Again, you guys have any questions, please ping in the Slack channel. We'll be more than happy to help you out. We'll try to solve this one. I think we have only left like 20 minutes max. We'll try to solve this one in the meantime. If we get through this, then we'll go to the maximum subarray. Product of array except itself. Given an integer array nums, okay, you have an array with the name nums. Return an array answer such that the answer of I is equal to product of all elements of nums except nums of I. Okay, at first, when you first look at it, it doesn't seem very intuitive. What are they saying? They're saying a lot of things in a single statement. But let's read this entire question first, and then we'll come back to things we didn't understand. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Okay, still doesn't give us enough. You must write an algorithm that runs in O of n time and without using the division operation. Okay, this is the only part I understood when I was first trying to attempt it. Okay, I can't use division. Well, that's good. I can start somewhere. And then let's move to the examples. You're being given an array nums of 5, 1, 2, 3, 4, and the output is 24, 12, 8, 6. But looking at it, seems like these numbers are being multiplied and the product is being stored in an array. But in what fashion? Well, let's come back to the question. The question will tell us. Given an integer array nums, this is my array. Return an answer, array answer. This is the array answer, such that answer of I is equal, to the product of all elements of nums except num of I. Okay, this is my answer array, this one. If I were to iterate over this array, can I say my answer of I can be this, it can be this, it can be this. Granted, I am using for loop for I is equal to 0, I is less than length and all that, and then I'll do I plus plus, right? So basically what they're saying is the answer of I is equal to product of all elements. Product of all elements. So this right here, answer of I, is product of all elements except the nums of I, except if you're iterating over n and you arrived at, for example, this right here, right? This is nums of I. Except this element, if you multiply these, you get 24. 4 times 3, 12, 12 times 2, 24. And then they have done the same. They move to 2 and exclude this, right? And then multiply this. 4 times 3, 12, 12 times 1, 12, right? So this is how they have created this array. So you have whichever element you're at, that's the one you have to exclude, and all other elements you have to multiply. Okay? I guess there's a message I can probably. Can we use the same problem finding the popular medicine in the database? Yeah, probably. You can.
So,
You have to think in patterns, actually. You have to think this pattern, not in terms of problems. If you can, so when you solve the question, you'll learn a pattern. If you encounter a problem in your healthcare industry that can use the same pattern, just go ahead and use it and find out. That's the best thing I can tell you. Okay. Since running off time, we need to rush this. Okay. So we understood this part, right? So does someone want to give it a go? I can give you 3 minutes to talk.
okay, so
Yeah.
the first thing that comes to my mind, although it's not the solution and it's the constraint they have told in the question, but I want to discuss is that the simplest solution would be if I create a loop and I iterate through the nums array and I multiply every number. Whenever some numbers comes in, I divide it, and then in the second iteration, whenever some numbers comes in, I divide that number, divide that string with that particular number, and then I'm gonna get my desired result. But they have said that we cannot do the division, right? We cannot
Right.
divide.
We cannot divide. Yes.
Yes.
That's where the actual trick comes in. Okay. I wish I had gotten like another half hour. I would have walked you through entire process that I've been through just to get to a solution that works. It's very interesting, and probably if someone is interested, they can connect with me some other time and I can show it to them. But we'll just, cut to the chase um, and just solve it. Okay. So the way I solve this question is by using the idea of prefix and suffix. Okay. And even if I think if you come here down in the topic section, you're going to see that it's talking about prefix sum, right? So you can find like questions around prefix sum within the LeetCode itself if you're interested in exploring this. It's a very useful concept actually. I solved this maximum subarray with the same concept. But anyways, a prefix would be something that comes before, right? Suffix with something that comes after. So before and after with respect to what? With respect to the nums of I, okay? Nums of I, the number that we're trying to exclude from the multiplication in the nums array, right? So let's say if I'm trying to exclude this, the prefix would be 1 and the suffix would be this subarray, right? Mind you, we're going to return an array, but we have to segment our nums of I into subarrays and then take products of these. But again, just using subarrays did not work for me. I implemented a brute force operation, but that ended up being giving me a timeout error saying that your solution is not optimal enough for it to run it, right? So how we're going to solve this is 1, 2, 3, 4. Okay, what is happening when we are multiplying? Let's say I'm excluding this one and I'm multiplying 1 and 2, and I'm trying to then multiply this. They said product of all elements except this. So we need to multiply 2 by 1 and then multiply 4 with it, right? So 2 times 1 is 2 and 4, and then the answer is 8. And we can store this 8 into a new array, right? Okay. But then when we move forward, then this 3 becomes available, and then 4 becomes unavailable. So then we have to multiply this. All right. Uh, Fair enough. I can multiply these. So what if every time I'm doing this, I increase my sliding window and decrease? That didn't work actually pretty good for me. So what I did instead is I use a prefix. I first calculated all the prefix and then suffix. Let me take a bigger example, -1, 1, 0, minus 3, 3. Okay, I multiply this when I'm excluding this, I multiply these, and then I multiply this separately, and then multiply these two together. But then I have to run two loops, right? Either I can just keep going and skip that, and for I and j, once I'm finished with one iteration, then I start iteration from here, then here, and then here, and then I keep implementing loops or probability recursion. A better way to do that is, how about if we run a for loop in forward direction and one in the backward direction. The forward one will calculate all the prefixes, and the backward one will calculate all the suffixes. Okay? And then multiply all the prefixes with suffixes. That will give me the product. I don't know if it's making sense because there are like multiple details to it. Are you guys able to catch it?
So what we are doing, we are creating two separate arrays, and in one array we are going to store the prefix sum, and in other array we are going to do the suffix.
Suffixes.
Yes.
You know why?
So that we can do some calculations and we can store that, we can get the final output. If you can make an array where I will tell you the suffix and the prefix, so that we can come to a conclusion that how we are going to what next step we are going to do. Either we are going to subtract or add or something.
Actually, I'd love to do that, but let's cut it short. You're on the right track, actually. That's the first thing I did, but there's one small optimization. You're going to be excited to hear that. We're not storing the product in two separate arrays. We're not doing that. If you see the pattern, if I am calculating suffixes, okay, if I'm multiplying the, let's say, if I'm taking this window right here, I have 4. Okay. So I multiply 1 by 2 by 4. So if I'm multiplying in the opposite direction, right? Multiplying in the opposite direction, and I'm going in the first direction, this 4 gets multiplied with this. And as this window prefix window increases, the suffix window decreases, right? But when the suffix window is larger, the prefix window is small. Let me try to redo it. I don't want to miss out on this. This is very important. Okay, first, if I'm excluding 1, my prefix is 0, right? There's no prefix. We're already excluding this. We already have suffix. But as we keep moving our prefix forward, our suffix window becomes smaller and our prefix becomes larger. So what you're seeing is the number of elements that are multiplying to result in prefix increases. And when it increases, the number of elements that give you suffix after multiplication, they decrease. So there's a relationship between these two. If in the order prefix is increasing, your suffix is decreasing. So you need to do like an inverse multiplication, smaller number with a larger prefix number, smaller suffix with a larger prefix. And if you keep multiplying like that, you're going to end up with this array.
So it seems quite confusing. Can you just write down the numbers after multiplication so that we can understand easily?
Sure. So we'll start with 1. 1 multiplied by 2, 1 multiplied by 2 multiplied by 3, 1 multiplied by 2 multiplied by 3 multiplied by 4. Okay, this is just your prefix window increasing. Imagine this, your prefix window increasing. Okay, now we'll write down the suffix window. Initially, your suffix window is 2 by 3 by 4, 2 by 3 by 4. And then it reduces to 3 by 4, and then it reduces to just 4. Okay, now either I can introduce a variable where I'm multiplying this, right? Okay, let's look at it this way. When your suffix window was this, what was there for you to multiply for prefix? this, right? Or maybe nothing. When your suffix window moved to this, in prefix, you had 1. So then you need to multiply this 1 by where you are getting the 3 multiplied by 4. I know I'm not doing a good job right now. I'm trying to explain this. Oops, all the drawings are gone.
So, yes, I would say just make 2 arrays. Yes, like this, and just write the final answers. What?
Okay. That's a good idea. I think we can. So if I'm excluding 1, then I have 24, right? 24, 2 by 3 by 4, 24. And then this reduces. Then we have 4 times 3, 12. 12 times 1, 12. 12, okay. And then when you move to this, excluding this, you have 3 by 4, 12, and then you have 4. Okay. Next thing is when you're doing the opposite iterations, you're excluding 4, and then you're multiplying 3 by 2 by 1. So 3 times 2 times 1, 6, right? And then you do 4 by 3. Am I going in the right direction? Am I multiplying it correctly? Okay, so first it will be 3 by 2 by 1. And then we'll exclude this, and it'll be 4 times 2, 8. And then we'll exclude this, it'll be 4 by 3, and this will be 12. And then when we exclude this, 12, 24.
No. So how can we exclude something? If we can exclude the we can get we can solve our original output. Just think about why we are making suffix if we can get the final. Compare your array with the original array, original output. So where is the suffix and prefix in this case in both of these arrays? Where is
So
this?
instead of at the same, so we have only 4 minutes left. This is the problem with having a small amount of time. I can't think clearly. So I'll share with you the solution. You guys go over it. I'll tell you the intuition behind it, how I solved it. Instead of computing prefix at every iteration and then suffix and then multiplying it, I am computing all the possible suffixes and all the possible prefixes and then multiplying all the elements in an order which they would appear. So I guess what you have to see is during an iteration, which elements are free to multiply. So if these two are free to multiply, you just take their product and this 24, and in these two prefix and suffix products that you have accomplished with 2 iterations, you just multiply these 2 elements. You find the sequence where these 2 will eventually multiply. And this will give you the answer. All I'm saying is 1, 2, 3, 4, right? So you are computing the, you're starting with the 2, 3, 4, right? Compute this, and compute this. These are all your possible prefixes, okay? And then go in the opposite direction, compute all the suffixes, and then establish relationship at what instance, what iteration of prefix, when a prefix was produced, a suffix was produced. If you can get those 2 things, you multiply them and then you have an answer. I'll share with you the solution, it will make more sense. I can
अच्छा
try.
सर
जी
हमारे पास सिर्फ 2 मिनट्स हैं क्योंकि मेरे पास अल्टीमेट आ रहा है बार बार 2 मिनट्स बाद ही ऑटोमेटिकली ऑफ हो जाएगा सेक्शन
Okay. Sorry I couldn't dive deeper into this. I'll try to do better tomorrow.
You have done a great job,
Thank
I
you.
must say, and we can clearly understand this. At least everyone now has a whole day where they can think about it, and
Correct.
it's a good practice. If your mind, just while doing any kind of stuff, if your mind is solving this question throughout the day, believe me, you are doing very good job. So guys, keep doing this, and I hope you will share the solution in this Slack, individual solution. What we were doing right, we have to come up with something related to the prefix and suffix, and in this way we can compute the products without division. So it's a good question to practice. And I'm really thankful and appreciate that Sir Talha, you are working on Sunday night. It's amazing to see you.
Thank you. Thank you very much for your kind remarks.
ओके, तो
Guys,
अब हम सेक्शन को सर एंड कर देते हैं, क्योंकि मेरे
जी।
पास ना वहाँ 7 AM